Next is MRI scanning or magnetic resonance imaging or nuclear magnetic resonance imaging. MRI provides much greater contrast between the different soft tissues of the body than CT does, making it especially useful in neurological, cardiovascular and oncological imaging. Unlike CT, it uses no ionizing radiation but uses a powerful magnetic field to align the nuclear magnetization of hydrogen atoms in water in the body. It is far more flexible than X-rays and CT scans and can generate three-dimensional images in any orientation and at any depth in the body. MRI is a technique that uses a magnetic field and radio waves to create detailed images of the organs and tissues within. Basic principle is that a body is mainly composed of water molecules which each contain two hydrogen nuclei or protons. This is the structure of each water molecule. The protons possess a positive charge and like as the earth rotates, they are all constantly turning around an axis which has their own magnetic field as shown in the figure. The water is distributed throughout our body in different ways and the MRI machine is able to see these water molecules or proton molecules and construct an image for us. And this is the basic principle of magnetic resonance imaging. In the simplified diagram of MRI machine, the magnet is shown as the green coils of wire and the magnetic fields produced by the magnet is represented by the green lines with arrows. This magnetic field is continuously present and in our example it goes from top to the bottom. And it contains as said earlier, the water molecules are made up of protons and this as magnetic field is given, the protons start spinning in their own. It can be taken in another view as a proton moves like spinning top in two axes and that motion is called as precession and the spinning speed depends upon the magnetic field strength. And the movement of the proton can be represented in a coordinate system consisting of x, y and z and the resultant proton vector is magnetic field vector is shown by the red arrow. As there are more protons aligned parallel to the external magnetic field, when MRI scanning is taken, there is a net magnetic moment aligned with or longitudinal to the external magnetic field as shown by the orange arrow and this magnetic field is along the z-axis. Magnetic field will be given along x, y and z direction and the resultant magnetic field will be along the z-axis. In the strong external magnetic field given in three directions, a new magnetic vector is induced in the patient in the z direction and this new magnetic vector is aligned with the external magnetic field. After protons are aligned along the external magnetic force, in order to get the energy, a radio frequency pulse is sent for energy exchange. As shown in the figure, for exchange of energy, the radio frequency pulse should have the same frequency as the proton's position frequency. Otherwise, proper energy exchange will not take place. So when a second radio frequency pulse is given through a radio frequency coil, then the protons absorb some of its energy and this absorption of energy changes the energy state of the low energy hydrogen nuclei. Once the low energy nuclei absorb the energy, the hydrogen nuclei change their spin direction and some of them become high energy nuclei as shown in the figure. That is, on receiving RF energy, the low energy nuclei, some of the low energy nuclei gets converted into high energy nuclei. The MRI machine has receiver coils that's shown in blue color, that receives the energy waves sent out by the nuclei. Having given up their energy, the nuclei change the spin direction and return to the low energy state that they were in before. It can be shown in another way. The RF pulse exchange energy with the protons as shown in figure A, and some of them are lifted to a higher level of energy and pointing down. It can be pointing down. In effect, the magnetization along the Z axis decreases as the protons which point down neutralize the same number of protons pointing up. The pulse which give out their energy, the protons or hydrogen nuclei which give out their energy have their resultant vector pointing downwards. As a result, the resultant magnetic field vector will be decreased, value will be decreased. As RF pulse is given, the new transversal magnetization moves around with the protons. Thus, for an external observer, this magnetization constantly changes this direction and can induce a signal in an antenna. That is, it can give out the energy. And this is the another figure. After giving out energy, some of the hydrogen nuclei will be in their energy state and some will give up their energy. The energy sends a signal to a computer. The computer uses a mathematical formula like Fourier series to convert the signal into an image using image processing techniques. Next is the main components of MRI system. The main components of MRI system are scanner, computers and recording hardware. And the main components of scanner are static magnetic field coil which produces magnetic field, gradient coil that produces the magnetic field in X, Y and Z direction, and also it has a radio frequency coils. And this is the detailed diagram. And this is the detailed view of gradient coil in both X, Y and Z direction that produces variations in the magnetic field. And this is the original figure for RF coil, magnet and gradient coils. And by using this MRI system, diseased tissues such as tumors can be detected because the protons in different tissues return to their equilibrium state at different rates. By changing the parameters on the scanner, this effect is used to create contrast between different types of body tissue. That means if a tissue is suffering from cancer or if malignancy, that will take time to return to the original state by which it is the cancerous tissue or body part is detected. This is the block diagram of MRI instrumentation. It consists of a magnet which is providing a strong, uniform and steady state magnetic field. Usually superconducting magnets are used. Different gradient coil system produce a time varying controlled magnetic field in different directions. To get a resultant magnetic field, the patient is kept in this gradient field space as shown in the figure. The transmitting and receiving RF coils are present surrounding the site on which the image is to be constructed. There is a superposition of the linear magnetic field gradient onto uniform magnetic field appearing on the patient, producing a three-dimensional coordinate system. When the superposition takes place, the frequencies of the nuclei will depend on the positions along the direction of the magnetic field gradient. This produces the projection of 3x, y and z gradients produces a one-dimensional projection of the structure of the three-dimensional object by taking a series of these projections at different gradient orientations. Using the gradient coils, a two- or three-dimensional image can be obtained. The magnetic field or gradient magnetic field can be controlled by computer. The transmitter provides the RF signal pulses. The received nuclear magnetic resonance signals is picked up by the receiver coil by the two-dimensional Fourier transformation and by image processing technique. The image is constructed by the computer and is displayed on the television screen. That's all. Thank you.